Good morning students. Today we will see partial fractions. Already we have seen two types. In this video we will see the remaining. So type 1. What was type 1? For factors whose denominators are containing non-repeating linear factors. Type 2. Containing repeating linear factors. Now type 3. What is type 3? When denominator contains non-repeating irreducible quadratic factors. So this is type 3. What is irreducible quadratic factor? Quadratic factor is a factor of degree 2. For example, if you take x square minus 1, okay, it is a quadratic one, but it can be written as x minus 1 into x plus 1. So it is not irreducible quadratic factor. What is irreducible quadratic factor? Which cannot be split. For example, x square plus 1, x square plus 2, etc. For such type of factors, type 3. We will discuss this by taking an example. See now, a fraction is given 2x square plus 3x plus 4 whole divided by x minus 1 into x square plus 2. See, so for all the problems, before deciding type 1, type 2, type 3 or type 4, first of all the fraction should be proper fraction. Already I said this point in the first video. So see that fraction. Here numerator's degree, highest term is x square, therefore its degree is 2. Denominator's degree, if you take the product there will be x cube term, therefore its degree is 3. Yes, therefore it is a proper fraction. After deciding that it is a proper fraction, now we have to decide the types. So in the denominator there is a linear factor which is non-repeating, only once it is appearing. Therefore for this type 1 we have already seen. What is another factor? X square plus 2, which is an irreducible quadratic factor, non-repeating. It is also appearing only once. For this linear factors already we have seen same procedure. So now I am splitting this. So for linear factor we should take a divided by x minus 1, seen in first video. For quadratic one, what is this factor? It is irreducible quadratic factor. See, for linear factor means degree 1. If the factor is of degree 1, what you should write? 1 degree less, that means 0 degree, written constant. 0 degree means here quadratic is there, no, 1 degree less means we should take linear factor 1 degree less, that is bx plus c. Linear factor general form is ax plus by, px plus q, etc. So bx plus c, it is a linear factor. So this is type 3. When irreducible quadratic factors are there, you are supposed to take linear factor in the numerator. Remaining everything same, taking LCM, equating numerators, finding ABC values, you will get answer. I will take LCM here. If I take LCM, what is LCM? X minus 1 into x square plus 2. Here a into x square plus 2 plus bx plus c into x minus 1. Now these two fractions are equal, their denominators are equal, therefore numerators must equal. If I equate numerators, this is equal to a into x square plus 2 plus bx plus c into x minus 1. This is equation Roman 1. Now to find ABC value satisfying this, there is a linear factor. You can find one value directly by making that linear factor 0. To make that factor 0, I have to take x equal to 1. Take an x equal to 1. 1 minus 1, 0. 0 into something, 0. If you take 1 here, 1 plus 2 is 3. That is 3a. Write x equal to 1 here. If I write 1, this is 2 plus 3, 5. 5 plus 4, 9. This implies a value has come. It is 3. Next, finding other two values. Those can be found in many ways. You can put some other values. You can write x equal to 1, x equal to 2, 3, etc. Listen here. Two values are to be found. To find two values, we need two equations. You can give some values so that you obtain two equations for two different values, solve them. Or you can also equate the coefficients. I will equate the coefficients of x square on both sides. On the right side, if I multiply, I will get ax square, whose coefficient is a. Here bx into x, bx square, whose coefficient is b. That's all, no other x square term. On the left side, it is 2. Already a value came, no, 3. If you write on right side, it becomes minus. 2 minus 3 is minus 1. Next, similarly, equating the coefficients of x or coefficient constant terms. So I am equating x coefficient. In the first one, there is no x term. Here bx into minus 1 minus bx, coefficient is b. On multiplying c into x, cx, coefficient is c. On the left side, it is 3. This implies c value is, b is negative, no? You write on right side, it becomes plus b. b already came, minus 1. Therefore, what is this? It is 2. So, ABC values have come. Therefore, the partial fractions of given rational fraction is equal to, we have split this as a divided by x minus 1. What is a? A is 3. So 3 divided by x minus 1. Next, plus bx plus c. What is b? Minus, no, minus 1 into x is minus x. Plus b is 2 divided by x square plus 2. These are the partial fractions. It can be written as 3 divided by x minus 1 plus, you can take minus common, or you can write 2 minus x, no problem, divided by x square plus 2. These are the partial fractions of given rational fraction. So here we are discussing type 3. Type 3 is what? Irreducible quadratic factors. But if you have irreducible quadratic factor, we take it as type 3. But in this problem, we have type 3 as well as type 1, non-repeating linear, non-repeating quadratic. Yes. Coming to type 4. What is type 4? When denominator contains a repeating irreducible quadratic factors. So what was type 3? Type 3 was non-repeating quadratic factors. Now repeating irreducible quadratic factors. We shall see this by taking an example. Please see. X square plus 1 divided by x square plus x plus 1 whole square. Yes. This is a rational fraction. See this. For all the problems, once again, for every problem of partial fraction, first of all we should see the fraction, whether it is a proper fraction or not. See the degree of numerator. Highest term is x square, therefore degree 2. Here x square is there, also whole square, therefore its degree is 4. It is proper. So after deciding this, it is a proper fraction. Now see the denominator. Denominator is containing a second degree factor, quadratic factor, which cannot be split. Therefore it is irreducible quadratic factor, and whole square is there. That means it is repeating by two times. So what to do? Both are quadratic factors. Therefore in type 3 we have seen, for quadratic factor we should take ax plus b divided by x square plus x plus 1. So this factor is repeating two times, no? Therefore you take some linear factor cx plus d divided by x square plus x plus 1 whole square. You should take like this. For example, if you have whole cube, then you should take this and 3 times, no, plus ex plus f divided by whole cube, like that. So here again, this is the procedure. For repeating irreducible quadratic factors, you should take like this. Now remaining again same. Take LCM. What is LCM? X square plus x plus 1 whole square. Here we will get ax plus b carefully. Here only one factor is there, therefore one more factor comes. And here it is cx plus d. Again equating numerators. On the left side it is x square plus 1. On right side numerator is ax plus b into x square plus x plus 1 plus cx plus d. This is equation 1, Roman 1. Now to get the partial fractions, we need to find a, b, c, d 4 values. So here there is no linear factor, no chance of getting one value directly. Now you take coefficients, x cube coefficient, x square coefficient, etc. Here highest is x cube, no, therefore I will equate coefficients of x cube on both sides. If I equate x cube coefficients, multiply this carefully, you will get ax cube, coefficient is a. Multiply the other terms, no x cube, no x cube. On the left side also there is no x cube term, it is 0. After x cube we need to find 4 values, so we should consider 4 coefficients. Equating x square coefficient carefully, ax into x is ax square, coefficient is a. b into x square is bx square, coefficient is b, no other x square on the right side. Left side x square coefficient is 1. Already a value has come 0, therefore if you put a equal to 0, b will be 1. Next, coefficients of x terms on both sides. You see carefully, ax into 1 is ax, coefficient is b. b into x is bx, coefficient is b. cx is there, coefficient is c. On the left side no x coefficient, no x term, 0. So ab already obtained, no, a equal to 0, b equal to 1. If you put this, c will be minus 1. 3 values have come. Now one more value. Equating constant terms on both sides. What is the constant here? b into 1 is b. Here only d. On the left side constant is 1. So this implies d is equal to 1 minus b. What is b? 1. So this is also 0. So a, b, c, d values have come. Therefore the given rational fraction x square plus 1 divided by x square plus x plus 1 whole square. We have split it as ax plus b. What is a? 0 plus b is 1. 0 plus 1 is 1 divided by x square plus x plus 1. Next, cx plus d. C is minus 1, no? Therefore minus 1 into x plus d. D is 0 divided by x square plus x plus 1 whole square. These are the partial fractions. You can write minus here, no problem, plus into minus, minus. So these are the partial fractions of the given rational fractions. This is type 4. So far we have completed 4 types. Type 1, non-repeating linear factors. Type 2, repeating linear factors. Type 3, non-repeating irreducible quadratic factors. Type 4, repeating irreducible quadratic factors. So we should apply these 4 types depending on the denominators. But for all the types, first we need to check the function is whether proper or not. If it is a proper rational fraction, then only these 4 are applicable. Okay, if it is if the given fraction is not proper, what to do? We will see those in type 5, please. We have seen 4 types. Now type 5. What is type 5? When the fraction is not proper. See this example. So here a fraction is given, this one, whose degree is 2, here also degree 2. Therefore it is not proper. So we should make it proper by division. So we have to divide x square divided by this factor. If you take its product, it will be x square minus 3x plus 2. You should divide this until you get remainder of degree less than this. Its degree is 2, no? Remainder should be first degree. Okay. We should divide with 1. So x square minus 3x plus 2. Subtract this. These are cancelled. We have 3x minus this. So its a degree, remainder degree is 1. You can stop this. So therefore, now you can write this given fraction as, what is that quotient? Quotient is 1, no? So 1 plus quotient plus a remainder by divisor. 3x minus 2 divided by x square minus 3x plus 2. This is the procedure. When the proper fraction is not there, improper is there, you should divide until the remainder is of degree less than this. Then you should write like this, quotient plus remainder by divisor. So now we have already split this. So again this is a rational fraction which can be split further. So I will take this now. 3x minus 2 divided by x square minus 3x plus 2. What is this x square minus 3x plus 2? Actually product of these two only. So in place of this you can take this product. What are these two? They are both linear, non-repeating, type 1. Therefore I should write a divided by x minus 1, b divided by x minus 2. So take LCM, a into x minus 2, b into x minus 1 divided by x minus 1 into x minus 2. These two are equal, their denominators are equal. Are denominators equal? Yes. If you multiply these two, you will get this only. So numerators must equal. Therefore 3x minus 2 is equal to a into x minus 2 plus b into x minus 1 Roman 1. Now find AB value satisfying this. You put x equal to 1. If you put x equal to 1, this becomes 0. If you write 1 here, minus 1, that is minus a. If you write 1 here, 3 minus 2 is 1. This implies a value is minus 1. There is another linear factor, therefore you can take one more value. X equal to 2, this becomes 0. 2 minus 1 is 1. 1 into b is b. If you put 2 here, 6 minus 2 is 4. Therefore, this 3x minus 2 divided by x square minus 3x plus 2 can be written as a by, what is a? Minus 1 by x minus 1 plus b, what is b? 4. 4 divided by x minus 2. So I have split this proper fraction into partial fractions. Now coming to our question. This question, it was x square by x minus 1 into x minus 2. This can be written as 1 plus this one, this rational fraction. In place of this rational fraction, I can write this. So minus 1 divided by x minus 1 plus 4 divided by x minus 2. Therefore, for the given fraction, these are the partial fractions. This is answer. Yes. One more important thing. Presently we are discussing concept. So I am going according to concept. After this I will make one more video on problems, objective problems. Then there we will have many shortcut methods. Directly you can write these two. We will see there. One more thing, you please observe this particular problem. Here what is this? It is of equal degree. When equal degree is there, what will be the quotient? 1. Quotient will be a constant. So how to write this quotient directly when equal degree cases? Here highest term is x square, no? Here x square coefficient is 1. In the denominator, x square coefficient is also 1. Without dividing, directly you can write this 1 divided by x square coefficient by x square coefficient. 1 by 1 is what? 1. Plus these are the two linear factors, no? Instead of this you can take a by one linear factor, b by another linear factor. That method we will see one more problem. Right, see another. Resolve into partial fractions. This is the fraction. Numerator's degree is 3, denominator degree is also 3. It is not a proper fraction. Division should be done. But here equal degree. In this equal degree, just now I said, you suppose this is equal to coefficient of highest term x cube is 1. If you multiply here, then also you get x cube here in the denominator. So x cube coefficient in the numerator by x cube coefficient in the denominator, 1 by 1 is 1. Plus there are 3 linear factors, all are non-repeating. For linear factors you should take constant, no? Directly you take this instead of division. Here it is capital C and this is small c. If the x cube coefficient is 1 in the numerator, 2 in the denominator, then what will be this? 1 by 2, like that. Remaining procedure is same. Again you take LCM. LCM is x minus a into x minus b into x minus small c. Here we will get x minus a into x minus b into x minus c plus a into x minus b into x minus c. Next plus b into x minus a into x minus c plus capital C into x minus a into x minus b. Denominators are equal, therefore equating numerators. X cube is equal to x minus a into x minus b into x minus c plus a into x minus b x minus c, b into x minus a x minus c plus capital C into x minus a x minus b. This is equation 1. Now there are 3 linear factors. You can put 3 values. See carefully. I will put x equal to a. If I put x equal to a minus a, this becomes 0. This becomes 0. This is also 0. 0 into something 0, 0 into something 0, 0 into something 0. Then I will be having a into a minus b, putting x equal to a minus c. On the left side we will have a cube. This implies capital A value is a cube divided by a minus b into a minus c. Similarly, you can put another value x equal to b, you will get b value. Similarly, that can be done. I will write here. If you put x equal to b, then you will get b cube divided by b minus a, b minus c. Here putting x equal to a cube by a minus b, a minus c. If you put b, you will get capital B, b cube divided by this. Similarly, if you put small c, c cube divided by c minus a into c minus b. These are ABC values. Therefore, answer for the given fraction x cube by x minus a into x minus b into x minus c is equal to, this can be written as 1 plus a divided by, what is a? This is a divided by, a means this one, a minus b, a minus c, by x minus a is there, a by x minus a, I wrote here. And what is b? B cube divided by b minus a into b minus c. B minus c by x minus b. And capital C is c cube divided by c minus a into c minus b by x minus c. These are the partial fractions. When they are of equal degree, you can take this simplification in this fashion. Yes. Next we will see another improper one. X cube divided by x minus 1 into x minus 2. See, numerator's degree is 3, denominator's degree is 2, improper. Moreover, it is not equal degree. It is of equal degree. We have seen 2 examples. Here you must make division. So you should divide x cube by product of these two. This is plus 2. So x square plus x minus 2. Dividing this, you should divide until you get remainder of degree less than this. So first we should take x now, taking x cube plus x square minus 2x minus plus. So we have minus x square plus 2x. Still degrees are equal. So you take minus 1. Then you will have minus x square minus x plus 2 plus minus. These two cancelled. We will have 3x minus 2. Therefore, this fraction, now it can be written as quotient. What is quotient? X minus 1 plus remainder by divisor. 3x minus 2 divided by, what is divisor? X square plus x minus 2. We have split this. So now again it is a proper fraction. This can be split. I will do here. What is this? 3x minus 2 divided by x square plus x minus 2. What is this actually? It is the product of these two. Both are linear non-repeating type 1. Therefore, a divided by x minus 1 plus b divided by x plus 2. Take LCM. I am taking LCM and I am directly equating numerators. A into x plus 2 plus b into x minus 1. This is equation 1. Find AB values. So by putting x equal to 1, this will be 0. If I put x equal to 1, this is what? 3a. Here if I put x equal to 1, 3 minus 2 is 1. Therefore a equal to 1 by 3. Next, put another value, x equal to minus 2. This will be 0. Minus 2 minus 1 minus 3b. If you put minus 2 here, minus 6 minus 2 minus 8. Therefore b is equal to 8 by 3. This is b value. Therefore now this rational fraction, proper one, 3x minus 2 divided by x square plus x minus 2 can be written as a divided by 1 by 3 by x minus 1. b is 8. 8 by 3 into x plus 2. These are the partial fractions of this. Therefore now this fraction becomes x minus 1. In place of 3x minus 2 divided by this, we can write 1 by 3 into x minus 1 plus 8 by 3, that is 8 by 3 into x plus 2. These are the partial fractions of this. So this is partial fractions. There are 5 types. Firstly, if a fraction is given, we have to see whether it is a proper or not. If it is a proper fraction, then watching the denominator depending on the factors. What is type 1? Non-repeating linear. Type 2, non-repeating linear. Type 3, irreducible, non-repeating quadratic. Type 4, repeating irreducible quadratic factor. If the fraction is not proper, how to solve this? If it may of equal degree or completely improper, these are the procedures. Definitely I will make one video on objective that will be very nice, very beautiful. Don't miss that.